So Cheryl, do you see it in the presenter mode?
I see your PowerPoint ready to go.
Okay, good.
Okay, it looks like our waiting room is just about clear, and I'll continue to admit those who come in, Dr. Ayanar. So we're ready when you are.
All right, I'm ready. I'll just get started then. Okay, good morning, everyone. So it's great to see a lot of students participating. I see like 54, that's great. Thanks everyone for your interest. I'm Raja Ayanar. I'm currently the area chair for the Electric Power and Energy Systems group at ASU. And this presentation is a brief overview of our program, the faculty in our group, the courses, the undergrad courses, and briefly touch upon some of the research topics. Right, so you may have already know about this. AUC has, if not the largest, at least among the top three in terms of the size of the power engineering program. So it's not just the size, not just the number of faculty, which itself is impressive, like 14 faculty in just the power area, and about 100 plus graduate students, research students alone. So that's a big group. So it's not just the size. In terms of the research expertise, the diversity of our research projects, the type of simulation and experimental tools and facilities that we have, that sets us apart from many of our peer universities in terms of power engineering research and education program. So we have among the faculty 3 members of the National Academy of Engineering. That is the highest honor in engineering. Any engineer, whether it's faculty or practicing industry engineer, can hope to achieve in their career. It's to be a member of the NAE. And it's very rare that just one group has as many as 3 NAE members. So in terms of the graduates, so our graduates have an excellent record with employees, with employers. Every semester I get emails from the industry, people saying, we need more of this kind of a student and so on. So it's they have built a very high reputation in the industry as well as in other graduate schools. I would also mention that in the power and energy area currently, it has excellent employment opportunities out of necessity. This area, the infrastructure development in this area has been neglected for far too long, that now there is a real need to build these infrastructures, power stations, transmission systems, and so on. And there is also a lot of new research topics like smart grid, renewable energy interface, which also needs more research as well as practicing engineers. So it's a great opportunity now to be in this field. It's very exciting. One thing unique here, unlike say software engineering or communications engineering, power engineering has to be done here, right? If you're building power stations and transmission system, it is here and cannot be outsourced. Okay, so that's the our group. I work in power electronics. Professor Corey Hedman, he is an expert in energy markets. And Professor Haidt, he recently retired, but he continues as an adjunct faculty. He is world renowned for his work in distribution engineering and power quality. Professor Holbert is a nuclear engineer, and he teaches several courses on nuclear engineering related topics. And Professor Mojde Korsan Hedman, she is actually our own graduate a few years ago. She's an expert in power systems, focusing more on the bulk transmission system, its protection, and even optimal scheduling. Professor Chen Lei, just like me, is a power electronics expert. Dr. Anamitra Pal is another power systems with specialization in synchrophaser and related wide area control. Professor Yangchao Chen is also in the high power electronics area. Dr. Shankar, she is an expert in cybersecurity and privacy as applied to power systems. Dr. Tylowski, he works in computer solutions of power systems, many modern techniques for power flow and things like that. Dr. John Andrew, he spent much of his career at GE. He is one of the 3 National Academy of Engineering members that I mentioned, and so is Dr. Jerry Haidt. Professor Vital, he is also an NAE member. He is, again, a world-renowned authority in power system dynamics, stability, and control. Professor Yang Wang, he is an expert in machine learning, and he does research in that area as applied to power systems. And many of his courses bring in the concepts of artificial intelligence, deep learning methods as applied to power systems. Dr. Meng Wu, she is also in the distribution level power systems, works on many aspects of renewable energy integration and reliability and power quality of distribution systems. Okay, so then let's get into the courses, especially the undergraduate power courses. 360 is the pathway course, and many of the 460, 470 level courses, 404 level courses in our area, they require 360 as a prerequisite. It's a 4-credit course. It has a lab. Then I will touch upon each of the other 6 courses, which are our main senior electives, and then also talk about the senior design. I will also mention that all of these courses listed, the senior electives as well as the 360, and also the senior design that is also offered online, except for 473 machines, which is yet to be recorded for an online delivery. All the other courses are available as online courses, and even the on-campus students can take that section as a hybrid course. Okay, so our department offers a concentration or a specialization in the electric power and energy systems area. If you're interested in taking that up and have that show up in your degree, the requirements are you should do the 360, then at least 9 credits of any of these courses, the senior elective 460s and 470s. And you also have a few other choices in terms of a 598 and with special approval. More importantly, you also need to do your senior design project in the electric power and energy systems area. What qualifies as belonging to that area is ultimately approved, decided by the associate chair. But roughly, it means that the mentor for your senior design project should be one of the power area faculty that I showed pictures of in an earlier slide. Otherwise, it has to be approved by the associate chair for undergraduate studies. Okay, so then this question about what power courses should you take? You cannot take all the 8 courses that I listed. So Our courses are structured based on the main subdisciplines or the subdivisions of the power area. So it consists of three major subdivisions. The generation, that is where you generate the electric power from many different types of fuels. And then you need to distribute and transmit and distribute that electric energy. He told he'll come again. That's what he told. Okay, so people have to mute. Okay, so the generated electric power that needs to be transmitted and distributed to the load centers. So that is a very big aspect of the power engineering. And the last one is the end use, utilization of this electric energy for many useful purposes. So you would see that our courses are structured in order to address each of these three subdivisions. Power generation includes the design of power plants, whether it is coal plant, gas plants, and nuclear plant, or even more increasingly renewable generation. It also touches upon, it's an undergraduate course. It's just an overview of the energy markets. Is also part of that area, power generation area. Then under T&D, transmission and distribution. So this area covers the main power systems analysis, power flow, protection, high voltage engineering, and again, increasingly power electronic based solutions of controlling the power flow in the T&D networks. And the last one, of course, is the end use. So most of the modern devices, they have some aspects of power electronics in it, whether it is home appliances or electric vehicles. You would see increasing penetration of power converters in most of these applications. And then electric machines, those are all covered under the subdivision 3. So systems, you are, am I muted? Okay.
No, you're okay. I was admitting somebody and I clicked the wrong button. Sorry about that.
No problem. Okay. So when we say power systems, obviously what comes to mind is this this bulk power system, like all these transmission towers and the big generation stations and so on. And that is the main aspects of power systems for sure. But the concepts that we learn here, they are equally applicable to some of these smaller scale power systems. So a few examples are shown in this slide. Power systems in a large aircraft or a large ship, they follow the same thing. You need to generate power. There's probably not much of a transmission because of the short distance, but you still need to efficiently and securely distribute power from the generators to the individual, the point of load. And also you need to make the end use devices efficient and so on. So there are a lot of applications beyond just the utility power that normally is associated with the power systems area. So recently we submitted a proposal to NASA, which is about building power systems in the moon for a kind of a semi-permanent human presence. So many of the concepts that we are proposing, they have parallels in what we do for the terrestrial power systems applications as well. Okay, so the next few slides talk about the courses corresponding to these three areas. And for each area, I will have kind of an introductory slide like this, showing some pictures of what that area is about. The first one is the generation. Right? So as I mentioned, now probably the most transformative factor in the future power generation area is the renewable energy. They are distinguished by their intermittent nature. They are renewable. They are, non-polluting. It's a lot of advantages, but the challenge is in making sure that we're able to take care of the intermittency and many other challenges these smaller scale but widely distributed renewable energy resources present. Okay, so on the power generation area, we have two courses. First one is the 463 electrical power plants. Both of these courses shown here, they are currently being taught by Professor Holbert. 463 covers all aspects of power generation, all types of power generators, whether it's fossil fuel based, nuclear, or renewable. Those are all covered in that course. It also includes, as shown in the bullets, some aspects of economics, under a given operating condition, which generator is the most economical to operate. We have some for base load generation, some for peak load generations. Those aspects would be covered in the 463. So I see that he's also now including some aspects of energy storage as well as part of the 463. 463 is focusing mostly completely on the nuclear power engineering, nuclear generators. So this is a course that you will not see in many other universities. We are fortunate to have a nuclear specialist in our group. So we have a few nuclear courses offered in our mix of undergraduate as well as graduate courses. So 460 covers the basic concepts of radioactivity, the fission and fusion theory, and then goes all the way up to the design of the nuclear fission reactors with some examples. Okay, then we move on to the T&D aspects. So the slide I chose to, the picture that I chose to put in for this is the blackout in way back in 2003, the Northeast blackout. So this is just to show that there are some real life major consequences of how we design these systems. So this 2003 blackout wiped out power for more than 50 million people in the Northeast and parts of Midwest and a large part of Canada. And it was attributed to an error, basically a software bug in an alarm system. So basically, the operators did not have situational awareness. So what could have been prevented as a very localized, small-scale blackout turned out to be one of the major events of that decade. Yeah, so it's both. So this is what is challenging. This is what makes our the power area that much interesting. It is real life situations. All right, so under T&D subdivision, we have two courses again, the 470 or electric power devices. So again, I must mention that when we say power devices, we're not talking about the power semiconductor devices, which is part of power electronics, but it's covered mostly in the semiconductor physics area. When we say power devices here, these mean power protection, like circuit breakers, relays, and the transducers, voltage, current sensors, and so on. Those are the power devices that are covered in 470. So the main focus here is the protection of transmission system and distribution system for various short circuits and other types of faults. How do you protect different zones and things like that? And given that these are extremely high voltage systems, like the transmission system can be as high as 500 kV, 500,000 volts. So insulation is a big part of this, and some of those insulation design and coordination are covered in 470. 471 is the let's say the bread and butter course for power area. I would even go as far as and say that if you're going to choose just one course in power area, it should be the 471. That's where we cover the estimation of the various impedances, line parameters, the basic power flow analysis, which is required for any type of power systems analysis. And then again, at the undergraduate level, some aspects of power system stability and dynamics and control will be covered in 471. And that is a great preparation for the many of the graduate level courses. The last area is the power utilization. And here I chose to put pictures of applications of power electronics, like in lighting, electric vehicles, home appliances, data centers. They are all powered by some form of power electronic converters. So even that, we have a course dedicated for power electronics. It's 472. It's called Power Electronics and Power Management. That is the full title. So here we cover the basic power converters, DC-DC converters, DC to AC inverters, and AC-DC rectifiers. And then we cover them in a more of a design-oriented analysis, and focusing on the most recent, most modern applications, like some are mentioned here, powering IT, electric vehicles, interface of PV and wind resources. Then 473 is electrical machinery. We have just one course on electric machines, so it covers all the major types, the DC motors, different types of AC, like induction and synchronous AC machines, brushless DC machines. So not only it covers the analysis and operation of machines, but it also goes on to cover how do you control these machines for whether it's adjustable speed machines or precise position, robotics, and servo motors. The control of those type of machines is also covered in 473. Okay, on the senior design projects, if you're doing or if you're contemplating the concentration, you're required to do this. Even if not, you may choose to do it in the power energy area. So these are some of the either current or most recent in the last year or so projects that were senior design projects that were offered and mentored by power area faculty. I'm currently mentoring a senior design group on this competition called the Solar Energy District Cup. This is a Department of Energy sponsored competition for universities all across the country. I did that last year also. So I advised two teams. They ended up being among the finalists. They did not actually win it. I'm hoping that this year the team can go on to win one of the three prizes offered. There are three districts, and the students are required to come up with solutions that maximizes the solar energy for those given specifications without compromising reliability and also economically viable. Okay, so then briefly about our research focus. There are two major themes that our research addresses. The first one is, I'm going as far as saying that it is a paradigm shift. So in the past or even current state of the art, there is a centralized generation in remote locations, and then power is transmitted through this large network of transmission distribution systems to the load centers. So from that, the paradigm shift is now you are generating power, ubiquitous power generation using the renewable distributed resources. And it's not only used up by the owner, but it's also offered for sale, either to the neighboring communities or back into the grid and so on. So that introduces a lot of opportunities, but also a lot of challenges. Currently, the power system is extremely reliable. Right? They talk about 6 nines, 99.9999 reliability. So you don't want to compromise that level of reliability that is kind of come to be expected of power grid. Anytime you turn on the switch, you expect the lights to be on, right? So with this unique challenges that the distributed resources present, we need to come up with solutions that make sure that we still are able to maintain that level of reliability and also the economy. So you don't want your power prices, electricity prices to go way up just because you're using non-polluting resources. So a lot of our research projects are covering many different aspects of this renewable energy resources and the aspects of distributed generation and what is its impact on the reliability of the grid and how do we address the challenges. This smart grid is kind of related. Smart grid, by definition, is a confluence of power energy technologies with communication and information technologies. So how do you, so it's, I talked about the challenges in the previous slide. So the smart grid is kind of the umbrella term for the solutions that go into making sure that they are reliable and economical and also many other value-added functionalities that were not possible with the present state-of-the-art art grid. Okay, then many of our research, they are funded by some large research centers. The major one is the PSERC, or Power Systems Engineering Research Center. It's a consortium of 12 universities and about 30 industries, and ASU is the lead university for this center. It has three thrusts. One is energy markets, other is T&D. The last one is the core power systems research concepts. So among the 12 universities, we have more than 40 researchers. And so many of our PhD students are funded by projects from PSERC. The other one, slightly more recent, is a center also in a sub-supported industry university cooperative research center, IUCRC. It's called as Efficient Vehicles and Sustainable Transportation Systems. So as the name suggests, it covers all aspects of improving energy efficiency and environmental sustainability of vehicles, ground transportation vehicles. So a big part of that is electric vehicles. And I'm involved in the center through our work on power electronics for electric vehicles. And there are many other faculty addressing different aspects of not just EVs, but all ground transportation vehicles. So currently it has 4 universities and about 15 industry partners. And once again, this is also led by ASU. Pictures of a few of our research lab. We have a high voltage lab. We have a modern power electronics lab, which is what is shown in the picture. And then we have a power system simulation lab. So almost any power system software, the full industry grade, not just a watered down student version, the full industry grade software for all aspects of power system analysis, designs, simulation. Those are available in this power system simulation lab. And we also have an instrumentation lab as applied to power systems, equipment and instrumentations. Recent additions to our lab infrastructure is a lab for synchrophaser technology, the picture on the top right. Phasor measurement units and using that to control the power systems. So that is the focus of the research supported by that lab. And the one at the bottom, this is the lab for machine learning applied to power systems. Okay, so that was my last slide. So thank you for attending, and I'm ready to take your questions now.
Yeah, if students would like to put them in chat, I can manage those. Otherwise, I'd have to unmute everyone. So you can either chat to be unmuted, or I'll read this one. So Dr. INR, there's a student, Scott is asking, are there plans to make 473 available online in the near future?
Okay, so it will take, I would say, about 2 years. Yeah. One thing, if there is high demand, what we could consider is we can offer that as a, so all the other courses, they have been recorded specifically for online delivery. 473 is not done that way yet because of faculty availability limitations, so on. But if there is enough interest, we could consider the 591 part of that to be delivered as a, when the instructor delivers it in class, it can be recorded and made available to the students. That is an option.
Yeah, Scott, please, you may have already done this already, but please email your advisor and we can look into that question offline. But thank you for answering that, Dr. Ayana. Thanks, Scott. And Jeff is wondering if we can see the recordings of this meeting. Yeah, they're going to be posted to the website shortly. We have the old ones, but we find these Zoom recordings are probably going to be better because the mics are better and the presentation comes across more clearly.
Can I say something real quick?
Yeah.
Just for the online students that are here, we have a section now on our electrical engineering website specifically for current, prospective, and newly enrolled online students. So a lot of the information is there, and there is a YouTube channel where we post a lot of this stuff. So go ahead and maybe bookmark that for yourselves. It's under students on the electrical engineering website. So if you want to go there, we're going to try to update that as often as we can with new information and new recordings.
Thanks, Gia. And then for Patrick is wondering about online students participating in research. And I can answer briefly that those do happen. And the best way to initiate that is to line up, to contact a faculty who shares a research interest that you have. And you can find that on the department website and the faculty bios. That's the best way to do it, and you can reach out there. The lab facilities are a little bit more complicated, but you know, if you can, we do have some abilities to do some remote into lab stuff. I'm not sure if Dr. INR has anything to add to online.
Yeah, so you covered most of it. Only thing that I would add is, so from time to time, some faculty have this research experience for undergraduate grants from NSF or similar programs. If that is the case, then they would be looking for undergraduate research students. So just contact the faculty, and if they happen to have that kind of a position available, they will let you know.
Thank you. Hey, Gia, do you want to take the next one about the pathways? Do you see that one there?
Sure. Is it possible to first take area pathways and then decide if we want to do a concentration? Absolutely. Just make sure that you take 360. And that's really the only difference in the program is when you select the concentration and power, let your advisor know, and you can do that up until you're almost ready to graduate. There's really no difference in the amount of credits. It's just taking 360 as one of your pathways, and you have to take 9 credits of technical electives in power, and then of course your capstone. So of course, if you take 360 and you're like, it's not my thing, you know, you don't have to declare the concentration, and your concentration only appears on your transcript. So you don't have to worry, even if you select the concentration, that it's going to necessarily put you in that box. So keep that in mind too.
Thanks. Yeah, and I would add, if the concentration is helpful for your resume and things like that, but it's also helpful if you're considering graduate study. If you want to, you know, be an electrical engineering master's student focusing on power, it helps to have more power classes, obviously. So that's a simple way of looking at it. But thank you. That was a great question.
There's a question from Chad that I think we skipped. If it's okay, I'll answer that one. Hi, Chad. You're asking if there's going to be an email with a link to this recording, and I will tell you that I don't typically send out that link to everybody, but it's very easily accessible on the ECDE homepage. You just go there and you go to the students tab and then look under undergraduate, and the pathways link is right there. You can see this recording there later today and past recordings. So please go there, and if for some reason you can't find it, email me directly and I'll be glad to help you.
Cheryl, I'm sorry. I don't know if anybody else had that problem, but I couldn't really understand what you said. I don't know if anybody else had that issue.
No,
Yeah, it's a little hard to hear, Cheryl, but I put the link into the chat. If you guys, the students, will scroll through the chat, there's a link to the pathway page where you'll be able to find this recording.
Thanks.
Thanks, Elizabeth.
Was my thanks clear?
Yeah.
Okay, good.
So just a couple more. It looks like Vinesh is wondering about research opportunities for the power area for that a second semester freshman might look into, and sophomores. Dr. Einar, do you have any thoughts on students early in their area and what they can do to get research experience?
Yes, so it's a similar answer for the online section as well. So just contact the faculty. You know, it helps that you know, if you've done their courses, and you know, that's one way that, you know, impress that how serious you are in this area, and research capabilities and so on. So it may be a little bit too early, but maybe in the junior year, senior year, you know, that is certainly a possibility. And again, as I said, there are this research experience for undergraduate, and if a faculty has that program, it's part of some of the centers that we work with. If that is the case, then they are actually looking for undergraduate researchers. So if there is a good fit, so just talk to the faculty members.
Yeah, that's a fantastic way to use office hours. So if you read a bio and you want to know, you can contact them. That's I don't want to speak for our faculty member, but that's often a more engaging office hours conversation than, you know, squabbling over a quiz result. So I highly recommend using your office hours to do networking and things like that. Dr. Einar, there's another, would you remind us of if people wanted to focus on transmission and distribution, the T&D classes, which are those courses again?
Yeah, it's the IEEE 471 power system analysis, and then the 470, which is the electric power devices.
Okay, I just put that in the chat. Thank you.
Sure.
So there's a student, Dale is asking, Dahlia is asking, I'm taking 360. Would it be okay to take classes with different concentration, example, power and circuits and technical electives? Yes, but Gia, do you want to handle that one?
Sure. So, you know, your pathways are really getting you into sort of the nuts and bolts of each specific area. The subsequent technical electives, if you decide that, you know, you don't want to focus in one area, you can certainly take other technical electives. The program is really designed to give you a broad sort of overview of what it takes to be an electrical engineer. Certainly, if you want to take some power classes, great. Remember, you have 15 credits of technical electives that you need to take in total. And then you also have that upper division out of department area, math or science. And for those of you online, typically you're going to be taking another EEE course because we don't have a lot of math or science classes offered online at the moment at the upper division level. So you could potentially be taking 18 credits of technical electives. So you could dabble for sure. And that's a great thing to do. Obviously you're taking 4 pathway classes as part of the requirements out of the 6. And you can also take the additional 2 pathway classes and we can use those as technical electives. So if you want to take all the area lab classes, that's up to you. Just tell your advisor and they will move those extra pathway classes to your technical electives. Does that answer, you think?
Yeah, I think so. Feel free to follow up if there's any, but it's not. Yeah, he says yes.
You're welcome.
Thank you. Are there other questions while we have? There we go. So, are there controls courses such as EEE 481 essential or recommended for someone interested in research in smart grids? So, Dr. Einar, is there controls courses you would, besides EEE 481, that you would recommend someone who's interested in smart grids?
Yes, certainly the controls course definitely helps. Like even for the 472, the power electronics course, I recommend students have done basic controls course. So I think it's 480, right? 480, yeah, and it helps with the research as well. Power electronics is all about controlling many different output voltage or current or power from the PV and so on. So controls background is almost a prerequisite for doing well in power electronics.
Thank you, Patrick. That was a good question. Other questions out there? Well, we're excited that so many students joined us today. Dr. Einar, you probably noticed the number got up about 80 students, which
wow.
is
That's
which
great.
is much more than we do it. It's we're joking a lot about whether the free pizza is really how we think it is.
So it's not that, yeah.
And online students, you never get the pizza anyway. So
We'll send it through the waves.
Yeah,
We'll
yeah,
do smell-o-vision. At some point we'll have
maybe we could
smell-o-vision.
Grubhub you some pizza. Just to, okay, there is one. Vinesh is asking one. Oh yeah, I think he didn't answer our question. He didn't hear our answer, but Vinesh, the best way to do, there are opportunities for second semester freshmen and sophomore to start inquiring about research experience. The best way that to do that would be to go on the faculty bios, read each faculty in the power area if you're interested in this area, and see their particular research interests. And then ask them, maybe meet them in office hours or sending them an email, asking them, introducing yourself and saying what you're curious about. It's best to connect on that area. If you're not ready to do that just yet, your time could be spent with those same faculties, asking questions about, developing an interest that's specific enough to do research. So I think that one was answered, Dr. Nairn. Well, I think that was our question. Oh, there we go. Oh, no problem. No need to apologize. We all need to eat lunch, I understand. So, but I think that's about it for questions. And Dr. Einar, we thank you very much.
Thank you, Bob.
And we're very happy that so many students joined us in this format. So,
that's right.
Yeah, and thanks for everybody saying thanks. Cheryl, anything to add to this wonderful event?
I think we set a record today for participants.
Wow,
I'm
that's
very
great.
pleased. So thank you so much, Dr. Einar.
Yeah, thanks, Cheryl. Thanks, Bob.
Appreciate it.
Well, thanks very much. I know a couple of us will stay on if there's any advising related questions at the end. You're getting many thank yous in there. So thank you, Dr. Einar, again.
Right, okay.
Oh, real quick, are there some names of major companies that hire out of ASU? Yes, we have many. Dr. Einar, do you want to throw some of those names in real quick?
Yeah, so both the utilities, SRP, APS here, and then many of the ISOs, California ISO, New York ISO, all of those ISOs they cover. They hire many of our graduate students, but also undergraduate students. Companies like Black and Beach, GE, Siemens, they hire power systems engineers. Then for power electronics, all the major PV inverter manufacturers. Even Tesla and other electric vehicle manufacturers. Yeah, those are all some of the names that come to my mind immediately. And even power management companies, Intel, Texas Instruments, Maxim, they've all hired some of our students.
Yeah, so a good time, if you have not already, is to create your or to manage your ASU Handshake account. Make sure your resume is good, but many internships, many career opportunities are posted through that site.
And I would also encourage you to reach out to the Fulton Career Center if you haven't already. They can help you with the CV as well. And as you add classes to your portfolio of learning, they can help you sort of like design descriptors in terms of what you've learned. You know, even though you haven't maybe worked in that sector, it's always good to have that kind of practical learning experience on there as well. So under the Fulton website, all of the organizations, research opportunities through Fulton are posted there, including the Career Center. So you can just type in Fulton Career Center on your My Search and it will come up. You can make an appointment, they'll do Zoom, they'll do interviewing, practice interviewing with you and all that kind of good stuff.
Wonderful, thank you. And then we should, I don't know if 471 is available in summer 21. Does anybody know that offhand real quick?
This time it is not being offered, but Dr. Iana might have more insight than I do.
Yeah, so Jeff, please contact your advisor to plan ahead to get that course done or make some changes to make it happen. Well, thanks again. Like I said, maybe some of the advisors can hang out if we have kind of follow-up questions like that. But again, thank you, Dr. Arenar, for taking the time today.
Right. Sure, thanks, Bob. So I will drop off now. Thanks, everyone. Bye.
Have a great afternoon. Bye-bye.
You too. Bye.
Bye.